Okay, so what problems didn't we finish? 50,
53E.
okay, all right, let me just write them down. 50,
Oh, this is not.
53,
No, 55.
55,
Yeah. 56E.
56.
56.
63. 73.
Any to add to that?
You know, tell me what?
We reviewed it.
I see.
Number
Did we do 72?
Oh, yeah. 72.
The right to have bear arms. You have the right to have bear arms. You have the right to bear arms. You don't have the right to shoot people.
Okay.
You have the right to have bear arms.
Adam, we didn't have 67 from this assignment. Unless it was a different one. Okay, let's go over these because we have implicit differentiation and if we can get through it, we might have some bonus.
Let's be quick.
So, well, I don't want to be quick. I want to be thorough.
I want to be efficient, please.
But
That's
efficient. Thorough, yet efficient.
I should pass it.
Okay, so we'll start with
Shall we?
55. Yes, we'll be doing screencasts for this week.
We're screencasting this week? Why?
Okay. Oh, you have 55? Great. But should I do it?
Yeah.
I should do it anyway, maybe just,
Oh, maybe I stopped.
okay, so y equals, well, we went over most of these the last class, if I recall. Okay.
Yeah, we went up against 5.
All right, so 55, 2 tangent of pi x over 4. So I'm just going to write that as pi over 4x. And it's at x equals 1. Find the tangent and normal to the curve. Okay, so we have to apply the chain rule here. The outside, that's like step 1, and then the inside is step 2. Okay. Helps us to think outside versus inside. We only have to worry about it, the chain rule, one time. In other words, we have the derivative of the outside, derivative of the inside. There's no inside. The 2, we don't do anything. The 2 just stays there. Okay, so remember when we do the derivative, if there's a coefficient, it stays there. It just gets multiplied to the derivative. So the derivative of the outside, that's going to be derivative of tangent is secant squared. Keep the inside the same. Times, now we want the derivative of the inside. So that's the reason I rewrote it as pi over 4 times x, because pi over 4 is the coefficient. So it's just going to be times pi over 4. Now we want to figure out,
Oh, that is easier.
yeah, because otherwise it looked like maybe quotient rule
Yeah,
inside,
yeah.
and that makes it
That's
a
what
lot
the
more
solutions
complicated.
manual had, so it looked
Oh,
confusing.
really?
What?
Yeah.
They had quotient rule?
Yeah, it put pot.
Well, that's,
That was when we got the one square there.
okay, well, I wouldn't bother with there was no x in the denominator, was it? It was just
No, they put it on top. They put pi x over 4.
pi x over 4. So I read that as pi over 4 times x.
Oh, I did.
Okay. Now, you have to be really careful when you plug this into your calculator, or well, actually, I would not plug it into the calculator since they're special angles. If you have secant squared, how do you interpret that? So it's 2
1 over cosine.
secant squared, and if x is 1, it's pi over 4. So it's 2 times 1 over cosine squared of pi over 4. Well, what's cosine of pi over 4?
2 over 2.
Root 2 over 2?
So what
Or,
happened to the other pi over 4?
oh, sorry, I forgot my other pi over 4.
I got you.
There we go.
Yeah, after.
Wait, I didn't do that, but I got the right answer. What is this cosine?
It's just secant, okay, so secant is the reciprocal of cosine, so I just interpreted that as cosine squared. So we just said that was square root of 2 over 2, or 1 over root 2, so when we square that. Actually, I'm gonna write pi over 2 out in front. One over root 2 and root 2 over 2 are the same thing. I just wrote it this way because when we take the reciprocal, when we square it and then take the reciprocal, this will become 1 over 2, and then the reciprocal of that becomes 2. So pi over 2 times 2 is pi. Now, what is the coordinates for the point? We have x, right? So that implies that y would be 2 tangent of pi over 4. Tangent of pi over 4 is 1.
I need to do the original equation.
To find the coordinates, you have to go back to the original equation to find the y value. The derivative just tells us the slope. But what do we need to write the equation of a line? We need point and a slope. So if we have the x value, you have to go back to the original to find the y. So we have the point is 1 comma 2. The slope is pi. So my tangent, so y minus 2 equals pi, and then x minus 1. And did they ask for the normal?
Yeah.
Okay, so normal would be y minus 2 equals negative 1 over pi, x minus 1.
So it's, oh,
Good. All right, next one. Can I erase or still writing? Okay. Let me look ahead. 56. Now, you said 56. I heard 56E. Was it
yeah,
56?
yes, 56E.
Can we just read off the answers
Yeah,
for?
I just didn't know if mine were right.
Okay,
Just
let me
look
go
at it, it
to.
was posted, so.
My birthday present.
Yes.
It was posted for Linda's birthday.
Oh, it was? I thought it was a joke. No.
Well,
No, the
it was a
solution-
joke we got it for her birthday. It was already posted.
No, it was it was for my birthday.
Walker, way to take
Okay, take a look at 56. Let's check our answers, and then you let me know.
Can we do 56E though?
Okay, let me explain what you have to do. So, if it says evaluate the derivatives, so A, it's just going to be 2 times f prime of x. So, when x is 2, we go to the derivative, that would be 1/3. Multiply that by 2, you get 2/3.
Oh, wait, this is totally different.
Do you want?
When I was trying to figure it out, like I tried to figure out what 2 of what derivative of 2 to what would give 1/3, and I couldn't figure out.
No, I mean,
Like, you
okay, so for 56, they give you those table of values. This would be a common type of question on an AP exam. They wouldn't give you all of them. They would give you like maybe one where you have to apply the chain rule and then just pick the values to plug in. But if you have 2 times f of x, the derivative is just going to be 2 f prime of x. So 2 f prime of 2. We said that was 1/3, so it's 2 times 1/3, which is 2/3. Good? For B, B is f of x plus g of x at x equals 3. So it's going to be f prime of 3 plus g prime of 3. That's all. You're just putting in, so f prime of 3 is 2 pi. G prime of 3 is 5. That's fine, because there's nothing you can do to really simplify that. Okay with that?
No, but for some reason E had, I think had something weird in the solutions manual, which was a little confusing.
It had something weird in the solutions manual? Okay, we'll take a look. Okay. All right, so for C, because I see a product, I'm going to use the product rule. And this is at x equals 3. So how do we do the product rule? It's going to be f times g prime of x plus f prime of x times g of x. Or switch them around. I mean, it doesn't matter. And then at 3, so we want f of 3 times g prime of 3
Keep the same amount.
plus f prime of 3 times g prime of 3. So f of 3,
Wait, that's,
It's not G prime of three.
it's just G.
oh, sorry. You're right. G of 3. So f of 3 is 3. G prime of 3 is 5. F prime of 3 is 2 pi. And g of 3 is negative 4. So 15 minus 8 pi.
Can you scroll up a little to D?
So then d is f of x over g of x at x equals 2. So this is the quotient rule. So low, d high, take high, d low, cross the line, and square the low. And we want to evaluate this at 2. So it's going to be g of 2 times f prime of 2 minus f of 2 times g prime of 2 all over g of 2 squared. And now we just plug in from the table of values. So g of 2, oh, what is g of 2? G of 2 is 2. F prime of 2 is 1/3 minus f of 2, which is 8. G prime of 2 is negative 3 all over g of 2 is 2 squared. So 2/3 plus 24 over 4. And that simplifies to,
37.6.
thank you.
Anything for you.
E.
Okay. We'll get E. Here, we'll do E here. E. So E is f of g of x at x equals 2. This is a composition because you have a function within a function. So think of the outside versus inside rule. Okay? So it's derivative of the outside. Keep the inside the same times the derivative of the inside. So it's, and if you look back in your notes, it's the same thing. I put f prime of g of x times g prime of x. Now we want to just put in, so it's f prime of g of 2 times g prime of 2. Whoops. Okay, g of 2 is, no, g of 2 is 2. So it's going to be f prime of 2 times, what's g prime of 2? Negative 3.
Yeah.
So then I look back, f prime of 2 is 1/3. So it's 1/3 times negative 3.
Wait, where'd the 2 go?
Where'd what 2?
That's what I got before, but I think the book said that was the answer.
The book does that as the answer.
Just kidding. Wait, G of X is 2 though.
G of 2 is 2, and then f prime of 2 is 1/3.
Oh.
So you have to use, so basically what you have to figure out what g of 2 is. Like you have to look,
That's what I'm
yeah, you have to look at the table for this, and then look back at the table for the f
But then
prime of that value.
Yeah, the only way it works is because G of 2 is
Is-
a value
Is a
in
value
the
in the table. If
But
they didn't give that to you, you
G of
wouldn't be
2
able
was
to
like
figure it out.
4, you wouldn't be able to do it.
Correct.
If you multiply G of X and F of X, you get the same answer. I don't know if that's a coincidence or.
I think that's a coincidence. All right, we're good? What about F? We need all of them?
No, it's just what you just did A through E.
Oh, I didn't assign the others. That was nice of me. Okay. I feel like all of that. What else was there? There was 63.
Yes.
63, particle motion. So 63, we have a s equals square root of 1 plus 4t. And we want to find the particle's velocity and acceleration at 6 seconds. Okay, so first thing I would do, if you whenever you have a root, a square root, cube write it in exponential form. So we're gonna rewrite that as 1 plus 4t to the 1/2. So when I do s prime, right, because s prime is my velocity. So we have 1/2. Keep the inside the same to the negative 1/2 power, and then don't forget, you have to do the derivative of the inside. So the derivative of the inside would be 0 plus 4, so 4. And then the 4 and the 1/2 will be a 2. And then this will be basically the square root of 1 plus 4t in the denominator. Right? Negative 1/2 power, put the square root in the bottom. I want to evaluate this, so this is v. So I want to figure out v of 6. So 2, and then square root of 1 plus 4 times 6, so 2/5. What are the units? It's meters per second. And then acceleration is going to be the derivative of velocity. Now,
Just that.
which is this. So I'm going to rewrite this as 1 plus 4t to the negative 1/2 power. If you wanted to, you could do quotient rule, but I just prefer to apply the power rule chain rule. So I'm going to move the negative 1/2 to the front. So that'll become negative 1. And then 1 plus 4t to the negative 3/2. Right, subtract 1. Times the derivative of the inside again, so times 4. So we get negative 4. And this will be over 1 plus 4t to the 3/2. Now, keep in mind that you need to be able to do this without a calculator. These are the types of problems that you wouldn't have a calculator accessible in the AP. So if you have 3/2 power, just remember that's the square root and then cubed. Remember, bottom number is the root, top number is the power.
Oh, so you square root it first and then cube it.
You could do either one. You could cube it and then take the square root, but usually it's easier to do the square root first.
Yeah,
and
especially without a calculator.
without a calculator. So if I have square root of 1 plus 4 times 6, because we want a of 6. It's a lot easier because this would be square root of 25 again. And so you get 5. 5 to the third would be 125. So we get negative 4 over 125. And what are the units for
Meters per second squared.
Good.
It's actually meters per second.
Thank you. Yeah.
Can we write, like second squared on the AP?
Yes.
Okay. Just checking.
It's just notation. It's just,
Is that the correct degree?
Like,
There's
you don't have
not-
to write second for second.
it's kind of like, it's kind of like when you work with surface area or volume and you say, oh, it's feet squared. There's no such thing as a feet squared. It's a square foot. But when we read it in notation, it looks like feet squares. But it's really just talking about the actual unit as a foot by foot, a square foot. So, okay, good with that? Can I delete? All right. 72 and 73. Oh my, 72. 72 is y equals tan 4x. What do we have to do?
Derivative.
Just derivative? What's y prime? Secant squared, keep the inside the same, times 4. So e. And then 73, which of the following is the derivative for cosine squared of x to the third plus x squared? So you have actually 3 things. You have to do the derivative 3 times here. If it helps you, write it this way. Remember when I said if you have a function like cosine, sometimes you'll have logarithms. We didn't get to them yet, but we will learn those derivatives also. Often you'll see the squared or the cubed. The power here, it helps to rewrite it so it's on the outside, so you can see that's the first thing that you have to do. So we'll move the 2 out in front. Do you see that? Do you want me to write the numbers so we know what order?
Yes,
So this is number 1, taking care of the power. Cosine will be number 2. the x cubed plus x squared will be number 3. So first thing, we'll move that 2. Everything inside stays exactly the way it is. Times, now we do step 2, so now we're on to the cosine part. The derivative of cosine is negative sine. And now we keep all of that inside the same. And now we're on to step 3. Derivative of that would be 3x squared plus 2x. Oh, and then we just have to match it. Wait, let's see. Oh, there's yeah, it's C. Sorry, they just rearranged a few things. They just moved the negative out in front, and they put the 3x squared plus the 2x out in front.
Would you not wanna like distribute that out so it'd be like -6x?
No.
Like you wanna keep
Almost always, especially like on the AP, they'll keep it in factored form. They won't distribute. Occasionally they will,
but yeah.
but you'll be able to see based on
Oh,
the
yeah.
answers that they have. Okay, we're good on that?
Did you post the answers to the worksheet or is it?
I thought I did.
Oh, I didn't check. It was
It's
just.
on, yeah, I saw it.
Oh.
You saw it, okay. The answers to the worksheet were posted on Haiku. Those of you that chose to do the chain rule was just extra practice. Okay. So what I will do, we'll go through implicit differentiation and implicit differentiation.
Is it harder than chain rule?
No, usually students find it's interesting because implicit differentiation uses chain rule,
Can
but
it replace chain rule?
it looks a little different. It can't replace chain rule. Nothing replaces chain rule.
Is it hard?
So chain rule is the simplest form of everything.
Chain rules it's something that won't go away.
Is explicit differentiation hard?
Implicit?
Implicit is hard.
Okay. Explicit differentiation is actually what we've been doing all this time. Okay, when I have y equals x squared, and I say find the derivative, we would say y prime is equal to 2x, right? So I have y equals x squared, so I'd say y prime is 2x. Or if I said y equals 4x squared plus sine x. Y prime would be 8x plus cosine. Notice on the right side are all my x's. And on my left side it's just y equals. This is explicit differentiation. We don't call it that, but that's what it is. So what is implicit? Implicit
The opposite of explicit. High five, Jordan.
would be find the derivative of this equation. So do you see the difference between the two? One of them is always y equals. This one has x and y.
Would you set it to y?
Okay, so the problem is if we set this, if we can solve for y and then take the derivative, that would be fine. But there's a little problem with solving for y here. Because when you take the square root, you would get plus or minus.
Yeah, we can just write it as mine.
It's a lot easier. You want to do implicit differentiation. So let's take a look at your notes.
I don't need that negativity, but let's just mash it. Wait for it.
Did you make all these notes?
I did.
Yeah, that was kind of fun.
It took me a long time.
So you just reuse it every year?
I reuse it, but I also change things each year. So,
As in like the example problems? Or
like this example, example 4, I added this part because previously I only had a curve and that was confusing, so I had to add an extra one.
Oh, that's nice.
So I kind of tweak things each year. So this was added to, this was new to this year. I like to add like the graphs where it's showing that it's like
Now
getting
with that technology,
locally
since
lin-
the color
local
calculator
linear.
now exists.
Yes.
Is it TI in 9 to name color?
So I still go through them and I adjust them each year, which does take time, but it's kind of like teaching. Your first year teaching, it's a little rough.
Is it the hardest?
Yeah. Or your first year at New Jew. No. Then you get used to it and you're like, all right, I'll eventually get there. Ah, here we are. Okay, implicit differentiation.
Yeah.
No way.
No, it's right there. We got it. It's right there.
Wait, it's not an apple?
No, it's not.
You're not using an Apple thing?
Oh my
Okay.
I didn't post a Word doc.
It's okay, I don't need it for this chapter because I already have half of the chapter filled in
Got it.
PDF.
I'm-
Oh my god.
It's okay.
Monumental moment, everyone.
Because the pen on the iPad was getting really annoying.
Oh, so that's the reason to buy
So
the
$1,300 fixes that problem.
Not
So he
just
buys the whole new.
So if only $1,300 could fix my
God,
pen.
listen.
Apple products are great, but you know what? I've worked with both, but I prefer.
Because it's a full computer.
But
It's
didn't
a
you-
full computer.
Didn't you hear last week when he made fun of you for having the same processing speed as a computer but not the same storage as it, and yet he got one? I found that comical.
And I fixed the storage problem too.
You just bought the more expensive one?
Yeah.
Yeah, money fixes everything.
Yep.
Okay.
I feel like there's an irony in this situation, but I don't know.
We're gonna let's all get surface
We're all gonna get
That
this.
was
I
fun.
would love for you all to have surface.
My dad has one. I'm just going to take it.
I mean, if we're paying $30
dad
a
has
year.
one.
I honestly think that this is the way that the future will be, because we're gonna be, almost all of our math books are now online,
Except for this one.
except for calculus, stats, and finite. Oh no, and geometry fundamentals, I think, but algebra 1, geometry, algebra 2, and pre-calculus are all online textbooks. So, no, everything's changing.
I don't like even like you're literally gonna come to school with just
They're gonna come to school and they're gonna take their notes. I mean, the thing is, you could do, I've had, like, you do your homework on your, and I had a student last year in my AP that did her homework on the iPad, and then she would email it to me.
Oh, should I start doing that? I've been.
You can email it to me.
Yeah, I've been
That's fine.
working it out.
And so that worked out just fine. Because, you know, if we can save paper. I do all my solutions on here. I don't necessarily print out all my solutions. But I will, you know, most of the other teachers, they write, you know, with a pen and
And then
paper.
scan.
I do and then they scan it if they need to. But I just rather be able to do everything on my own here. Okay. We ready? Implicit differentiation? It's good. It's fun. Don't worry. All right. How do we differentiate that equation? Okay. So differentiate means find the derivative.
Oh, okay. That's
Okay, so derivative. Now,
Oh, that's on this test, isn't it? Differentiability. It's gonna be on the test
Differentiability.
on the fourth, huh?
we have a quiz on Friday, right?
there's a quiz that's just on
Chain
rule
rule and
and
implicit.
implicit.
Oh god.
See, it's not-
this Friday
That's
is not
Friday?
gonna have like acceleration, velocity, it's not gonna have that, right?
No, I think it's pretty straightforward. It's
Can
not,
we get a
it's-
little practice quiz?
Yeah, I have a practice.
Oh, yay!
Perfect.
Okay. So x squared plus y squared equals 9. So that mean, what does this mean exactly? This means, can I find the slope, right, here, here. I can't find, here it would be undefined because that would be a vertical slope. But anywhere else on the graph, I want to be able to find the slope. Okay, it has a tangent.
Why is it a circle?
This is just the example that I'm starting with. It doesn't
But I mean, like,
have to be a
does-
circle.
There's like x
So-
squared plus y squared.
Well, x squared plus y squared is the equation of a circle.
Oh, it is.
And then
Okay.
Always.
radius
Okay,
squared.
so if it's of the form x squared plus y squared equals r squared, that's a circle. I know some of you had conic sections with ellipses and parabolas, and I know it depends on where it fell. Like if you went on SIEP, EIEP, you might
Oh,
have.
Oh yeah.
We
were on
Yeah.
EIP.
Okay.
I think I give differentiation.
But like an ellipse is more like the oval shape, but depending on what you had, there are figures. This is not a function, but we can still find its derivative everywhere except for these 2 points. here, and here. So since it has slope everywhere else, I want to come up with a formula for that. Okay, so this is what I was just saying, has at nearly every point.
Nearly.
Just those 2 points, negative 3, 0, and 3, 0 are the only places where it doesn't have a defined slope. So we are going to find dy dx using implicit differentiation. Implicit differentiation just means that I'm working with more than one variable on the same side. Previously, we had the y on one side and just x on the right side. Now they'll all be mixed in together. And we can't there are cases where we can't separate it. Okay? So we're going to treat y as a differentiable function of x and differentiate both sides of the equation with respect to x. So here's what I'm going to write. We want to find d dx of x squared plus y squared and do d dx of 9. So just like in Algebra 1 where you had to balance the equation, whatever you do to one side, you have to do to the other. Which actually we were doing previously, just to show you. When I had y equals x squared, we really were saying find d dx of both sides. D dx of y is dy dx. D dx of x squared was 2x. It's all about notation, okay? So sometimes you would see me write y prime. Y prime means the derivative of y with respect to x. Okay, so do you see this example here? Now we want to apply that over.
So that's really what we're doing in the other one.
We were doing this.
But like we weren't writing it that way.
We just weren't writing d dx of both sides. It wasn't necessary because d dx of y is dy dx every single time. But what happens when we have y squared? Okay,
We're gonna see
no
right now.
longer, the derivative of y squared isn't dy dx. Okay, so we'll, oh, I didn't leave a lot of room for myself here. Oops. Okay, we'll just go through. So d dx,
Just zoom way in so you can.
it's
type in
okay.
a little smaller.
I'll manage.
Problem is if I'm in.
That's the main question.
Oh, well, I'll just rewrite.
Oh my god, there really isn't that much room.
Okay, I'm gonna have to write over here.
I'm gonna start over.
I wanted to fit 3 lines and, oh well. Now, I'm writing out a lot of steps for this first one, but you don't have to write out every single thing. You'll notice that d dx basically just distributes to everything. Okay. So d dx of x squared, so whenever these two variables here are the same, so here's an x and here's an x, it could be t, you know, sometimes when we do velocity or acceleration. Whenever these two variables are the same, we just differentiate like normal. Differentiate means find the derivative. What's the derivative of x squared? 2x.
Why is it y?
Okay. Now, this next one. What is the derivative of y squared with respect to x? So we're going to start out, the first part is going to look the same. It's going to be 2y. And then we're going to multiply it by dy dx. Because y is some function of x. So this is really applying the chain rule. We're saying the derivative of the outside, the inside is y, times the derivative of the inside. What's the inside? It's y. So it's dy dx. Just know that anytime that these variables are not the same,
You
you
just
have
put
to add in a dy dx.
You just put that variable
So
on
what
top.
would that dy dx be? What if it was a y?
Oops.
Yeah. Well,
What if it's what?
What would the dy dx be? Like, what are you multiplying to y by?
This is our derivative.
Like, we're actually multiplying by the dy dx.
We're going to be solving for dy dx in the end.
So it just
Oh.
you just put whatever variable on the top. Like,
Yeah, pretty much.
Okay.
Pretty much. This right here is actually the chain rule. That's why I said it's applying the chain rule, but it doesn't look like chain rule. Our inside function is y. and y is a function of x. That's why I said it gets a little complicated. Sometimes if you just kind of memorize the notation,
But then,
but I want you to have the understanding
then-
also.
but
What
is
if-
it, is this like full chain rule? Cause like, you're not keeping what's the inside the same part. It's not really that.
You are, yeah. Y is inside 2.
Because it's.
Here, can I?
DDX is outside, it's.
Here.
I'm confused.
If you have y squared,
Yeah.
think y is whatever, something inside, right?
Yeah.
So what's our rule? It's going to be 2, keep the inside the same, right? Times the derivative of the inside.
Oh, in respects to X, it's dy.
But if I erase the word inside and replace it with y,
Derivative of y is the same as dy dx.
okay? It's just, that's why I said it's applying that chain rule, but it looks a little bit different. So if you prefer, I like you to write dy dx to get used to that notation, but you could also write, some people like to do 2x plus 2y, y prime equals 0. It's the same thing. I like using dy dx because when we work with multiple variables or when we change to t and, you know, when we have our position, velocity, acceleration functions, it's good to have this notation because it explains a little bit better what we're working with. Okay, so now we want to solve for dy dx in terms of x and y together. Okay, so I had 2x plus 2y dy dx equals 0. So I'm going to subtract 2x from both sides. And then what?
Divide by 2
Yeah, just
y's.
divide by, so I'm going to divide both sides by 2y. Running out of room again. So I have dy dx is negative x over y. Now what does that mean? What is dy dx again? Slope of the tangent. Okay, so that means, first of all, I would need to know a point. So for example, 3, 4. At the point 3, 4, what would dy dx be? So here's, yeah, so 3, oh wait, not 3, 4. That's not going to work. It has to work for the equation of x squared plus y squared equals 9. I should have used it. I should have used but no, 2, 3 also won't work. But if you have a point here, let's just, it would have a root involved. But if you had a point on the circle, if you plug it in, it will give you the slope of that tangent.
So let's say 3/4 did work, would it be?
Yeah,
negative 3
you
over 4?
exactly.
So couldn't we do just one of the x-intercepts?
We could. Yeah, you could do like 0, 3. You'll get 0. Basically what I'm saying is if I give you an x value though, it's going to give you 2 different y values.
Y
Yeah, you could do y. Yeah, that's fine.
Okay, let's look at this one. dy dx, if y squared equals x, what does y squared equals x look like? It's a parabola, but it's not up and down, it's sideways.
This starts at 0.
Right, so kind of.
That's root of x.
Okay, so that looks like that. So find the slope at the point 4, 2 and 4, negative 2. So I want to take d dx of both sides. On the left side, because it's y squared, it's going to be 2y dy dx. What's the derivative on the right side? 1. So dy dx is equal to 1 over 2y. So if I want to find dy dx evaluated at 4, 2, so kind of imagine here's my point 4, 2.
Is that the sign for evaluated?
Yes, the line next to the dy dx just means my slope or my derivative evaluated at the point 4, 2.
And because you have X and Y, there's 2 points there.
Right, you
Yeah.
mean here?
Yeah.
Cause I have another one right.
No, because there's an X coordinate and a Y coordinate in evaluate that. Because previously it's just been evaluated at X equals whatever.
Right, I would just put
That's-
x equals, but now
Because
with
we're-
implicit differentiation, we
Yeah,
have
yeah.
x and y.
Yeah.
So that's exactly the reason why we wanna put in the whole point. We don't just write x equals 4 because look at our slope. Our slope doesn't even concern x. It only has y. So we only have to plug in 2, so we get negative, or sorry, 1 over 2 times 2, so we get 1/4 here. That makes sense, right? You can kind of picture the tangent line there. And then this one becomes 1 over 2 times negative 2, or negative 1/4. So you can kind of imagine your tangent slope here would be negative 1/4. So you can kind of visualize that.
Can we speak more of this than the chain rule? Does this make sense?
Wait, we didn't even get into this though, so. hold
This
on.
is just the beginning.
Oh, sorry.
Okay.
Did I speak too soon?
Yeah, you did.
I don't really understand what DYDX is.
I don't like it, no.
Like, what is with respect to mean? The derivative of something with respect to.
Evaluate at that. Oh, wait, no.
What do you mean, what does dy, what does dy dx, when we talked about the notation in the very beginning with derivative, I introduced dy dx. We are finding the derivative of a function with respect to x. It's kind of like f of x. So when I say a function f of x, the function, the output, is based on the input, right? What is your input? It's the x values, your domain. What can you plug in?
Then why can dy dx have y in it? If y is also part of the input.
Because when you have an x squared plus y squared equals 9, like we had on the first page, the function, well, it's not even a function, but the equation itself is based on x and y now. It's not just defined as y equals. There could be more than one value that makes that equation true. Okay, so this is almost identical to the very first example, so you want to take a minute just to find the slope of the circle at the point 3, negative 4. So we want to do d dx of both sides.
Is that going to be the same for every circle?
It is. The slope for any circle will always end up being that same formula. Because what happens, right,
From 0 on the right.
it's always going to be 0 on the right. So here we get 2x, and then we get 2y dy dx equals 0.
Then how would you check something like this on the calculator? Just like how do you graph like circles
So what did,
Do you have an 84?
and stuff? Yeah,
You have a Connix app?
I guess. No, I don't think so. But I probably.
yeah, we do.
If you have an 84, you do.
Oh, where?
Won't it always equal the negative x bar?
Yeah, that's what we were just
Is
saying.
that Smart View program you
Oops.
use free or no?
It is not free.
How much did it cost?
It's about
More
100.
than you can afford.
It's a school thing, so it's a lot. I already looked it up.
Or lose money on the Surface Pro in order to.
Yeah, it's a school thing. I don't see why you couldn't buy an individual license, but they're like $160.
Okay.
We're just gonna have a tutorial.
No, I'm
Don't
not.
worry.
I'm not doing that. I'm not doing that. I can just pull out my calculator.
Yeah. We don't have calculators.
Yeah.
Are we okay with that one?
Just computer for them, but definitely for you.
So
I
we,
wanted to
when-
know
Every
if I
single
had
circle-
calculator.
It's
So we wanna
it's
get to
3
the
negative
point
4
where
is
we-
basically. It's not negative 1.
Yeah.
But the formula is negative x over y,
No,
so
but-
it's negative 3 over negative 4.
Oh,
You said it's
Oh,
a
so you
shirt.
want us to be able to like look at that and
You
not
wanna-
have to go through that
wanna
process,
stop
right?
eating?
Just to look at it and say, I know that's what this derivative of a circle is.
Yes, okay, so
Yeah.
this would be one, if you have, let's say, an example on the AP test, and you have a circle, you could jump right to that conclusion. I can pretty much guarantee that you won't have a circle on your quiz or your test.
Oh, so we won't on our quiz or test?
I'm not gonna give you the equation of a circle, but I'll give you something that you have to do implicit differentiation for.
So we know it's negative x over y.
So, like example
No, we won't
3.
have, yeah, okay.
Okay, so let's look at the next one.
It folds flat so you can flip it and make it.
Okay, so I want to take d dx Okay, so I want to take d dx of both sides. Now remember, if it has x in it, we just take the derivative like normal. But if there is a y, then you always have to add, or not add, but multiply on the dy dx at the end. That's really all you need to remember. If you have y, well, what would be the derivative here? It would just be 2 times the derivative of y. Remember, coefficients just get multiplied. Constant multiples just can move to the front. So it's 2 dy dx. Okay, now I'm going to do the derivative. Let's distribute the derivative here. So the derivative of x squared is going to be 2x. Good. So then we do, think, this is really chain rule. Derivative of the outside would be cosine. Keep the inside the same, times the derivative of the inside. The inside is our y. So it's times dy dx. Now, this one looks a little different than the last one because we have 2 terms that have dy dx. So if I'm solving for dy dx, I want to get everything, all the dy dx's on one side. So I'll bring, it doesn't matter which one you bring over, it's the same idea. But then I want to factor out dy dx. And then you just divide by what you were left with after you factored. So I'm going to divide both sides by the 2 minus cosine y to get dy dx equals 2x over.
How do we show that it's always positive?
There's 2
Oh.
minus, there's always defined.
It's always defined. Okay, so how do we show that it's always defined? This is always defined because what is cosine? Cosine is always going to have a range between. So cosine of y always has to be between -1 and 1. Remember, it oscillates between -1 and 1. Will we ever have anything that would give us something undefined in the denominator?
No.
No. So
Never hit 0.
oops. Right. Okay. Okay, so here I just kind of summarized what we did. So step 1 was differentiate both sides with respect to x. Collect the terms of dy dx on one side. Factor out dy dx and then solve. So factor it out, and then when it says solve, usually that means just divide. Natalie?
And if there's something like cos 2y, when we have.
Yeah, but that's still cosine of 2y is still going to have a range
No,
of.
no, no, I don't mean for that, I just mean if it was up there, would you multiply cos 2y times dy dx times 2?
Oh yeah, you would have to multiply by 2 then.
By 2,
You would have to apply the chain rule again.
okay.
Yeah, multiple times. All right, I think, how much do we have? Do we have time? All right, I'm just looking how much further we have.
When we have to do the power rule on it, not power, the multiplying rule on
Product
the
rule,
product.
we have to do it here.
Okay.
So I'm going to do d dx of x squared minus xy plus y squared equals 7. Oh, thank you. And then we'll evaluate it at that point.
So we have to do some kind of rule in this since it's xy.
Yeah, we have to do the product rule.
Oh, no.
Okay, let's do derivative of x squared is going to be 2x minus, okay, I'm gonna put parentheses just because when we do the product rule, we end up with a sum, so I just wanna make sure that we remember to distribute that minus sign. So let's just look at x times y.
Just x plus one.
So, what is the product
X
rule?
derivative of y.
Okay, so the first, so that's gonna be x. The derivative of y is dy dx. Plus, okay, now derivative of x is 1 times y. So remember, it's first times the derivative of the second plus derivative of the first times the second. Plus, now we have to take care of y squared. We've done that a couple times now. So it's going to be 2y
Why doesn't the y
dy
have to be
dx.
Like when you
Because
do
it was
y.
keep the second part the same. Remember, it's really x times y prime plus 1 times y. Derivative, this one stays the same, derivative of this. Now derivative of this stays the same. When we say y stays the same, we weren't doing the derivative of y for the second part.
Okay.
It just stays y. And now I have dy dx in two different locations. I mean, it looked a lot worse. That wasn't too bad, was it?
It was pretty bad.
That was bad?
That was pretty bad.
I'll distribute the minus.
That's my.
Okay, now we want to get these two terms on the same side. And the other two terms we're going to move to the other side. I'm just going to rearrange this as 2y dy dx minus x dy dx and make this a y minus 2x on the right side. Just so I don't have a negative in front, but honestly it's fine. Now we factor out dy dx and we get 2y minus x equals y minus 2x. Divide both sides.
So 1 minus 2x equals, or 1 minus 2x.
So y minus 2x over 2y minus x. So now we want to evaluate dy dx at -1, 2. What do we get? 4/5? Okay, so that was all the hard work, because if we're finding the tangent and the normal, they gave us the point. So we don't even have to worry about plugging it in. It's just y minus 2 equals 4/5 times x plus 1, and the normal would be y minus 2 equals -5/4. Oops. And then x plus 1.
You can say face
That's
if you're
a
not
lot
excited
of-
to teach this next one.
No, this next one's kind of neat, but it's some work.
Yeah, I can tell by the amount of space you gave us.
Oh my gosh.
It's a lot.
Okay, so just like with regular derivatives, you can have second, third, fourth derivatives. With implicit differentiation, we can also find derivatives of a higher order. So the first thing, in order to find the second derivative, we know that we have to find the first derivative first.
Is that like the sign for to find the second derivative? Like
Yeah,
prime?
so remember, it's the second derivative with respect to x. So remember, it's finding the derivative again with respect to x with respect to x. That's basically,
So what? 2 prime.
it's kind of like when we did acceleration and it's per second squared, but we say it's per second per second. The same thing is true for derivatives. It's with respect to x and then with respect to x again.
Why are we with respect to x again?
Okay, I'll explain. We're going to do d dx here. And then when we get the result, we're going to do d dx again. See, we're doing,
Oh, okay.
but it's
So
always
that's
with
like
respect
just
to x
double
for now.
DXs.
Right. Okay, so what's the left side look like? It's gonna be 2y dy dx plus 2 derivative of y is just dy dx. On the right side, that's just a 2x, so 2, and the 1 goes away. Okay, let's factor out our dy dx. We get 2y plus 2 in parentheses. Okay, next we'll divide. And then we also want to simplify. So if I have 2 over 2y plus 2, yeah, definitely reduce it. It just makes things easier in the end. Because we're going to have to do the derivative of this. So if you don't simplify, it just gets more complicated. So 1 over y plus 1. Okay, there's our first derivative.
So I can sense the quotient rule.
Okay, so you could use quotient rule, or you could write y plus 1 to the negative 1 power and use power rule, chain rule.
Opposed to
Like
quotient
power
chain
chain.
rule.
What do you prefer?
Let's
It's
do- let's do
it's
chain
honestly
rule.
it's the same amount of
Well,
work
they're
either
both
way.
chain rule. They're both chain rules.
They're both chain rules. They're both implicit
Let's
differentiation.
do quotient though, because I don't know how to do quotient.
Quotient rule?
Let's do that.
Okay. It really makes no difference. So, we are going to take, now notice, let me write this out so you guys understand. It's d, we're doing d dx
Of something with only a y.
of both sides again. That's really what we are saying. So when I say take the derivative of dy dx with respect to x, that's how we get the d2y.
Oh, okay, that makes sense.
Do you see
And then
it?
it's dx basically parentheses.
So it's d2y equals dx.
But the whole,
But-
the dx is.
Right, it's just, when we write this in notation, we just put the 2 next to the x. We don't put it in parentheses, because you should recognize it's not dx squared, it's dx basically.
That makes sense.
Okay, I know, sometimes it's the notation, it looks a little confusing, but I hope that that made sense how we get that d2y over dx2. Okay. All right, you want to do quotient rule? Quotient rule's fine. If you want to do y plus 1 to the negative 1, that's fine also. Low d high. So low y plus 1, d high, that's times 0. Take high, d low. Derivative of y will be dy dx plus 0. Cross the line and square the low. Okay. Good so far? Questions with that step? Now the whole term, that first term, it just ends up being 0. So I really have a negative dy dx over a y plus 1 squared. Okay, that's not our answer.
We gotta get rid of the D.
Because we have to use dy dx here and plug it in there.
Whoa.
Wait, what? What?
Oh, I
What?
see it.
Oh.
I see it.
Just make it negative.
We gotta plug that in, yeah.
Whatever that is.
So now we have to plug in a negative 1 over y plus 1 all over y plus 1 squared, which ends up being what? How about negative 1 over y plus 1 to the third?
Hmm?
Hmm?
You
What?
read it a little wrong. You said y plus 1 to the third, so I don't know.
Oh, and I wrote y plus 3. Got it.
Wait, how does it end up being the same with product rule? I did it with product rule and ended up with negative 1 over y plus 1 squared.
Just remember, this is negative 1 over y plus 1 to the first, and then if I multiply by the root, remember,
Are we done now?
Oh, it's well, maybe.
Are we done now? No.
so do you see, if I,
Yeah.
dividing by a fraction means multiplying by the reciprocal?
Okay, now I got it.
So this is our final result. Yay. Well, it was a little bit of work, but it was still pretty neat.
Are you done now?
That's fine.
Just checking.
One more page. With this
No, no,
problem?
no, with
Yeah.
this problem.
Yeah, she said
Oh,
that-
the problem's done.
I get a different result when I use the product rule.
How did you use product rule? There's no product rule at all.
I mean, not product rule, but just bringing down the -1.
You did it good.
Somebody get a message? Okay.
So it was y plus 1 to the -1. I brought down the -1.
Y plus 1 to the -1. So this is my y prime. Okay, so I want to do the second derivative.
Oh, times the 1. I see what you're saying.
That was
This one.
okay.
Can I switch to what the answer is? Wait, how come?
I said you'll have most of your bonus. I didn't say you'd have all of it.
Wait, how come you went from? I don't know. How come the bottom is x squared, not like I'm just not sure.
You mean it's really dx. So we write that as dx with a 2.
So like there were parentheses around d and x. And
Yeah, we don't put the parentheses. We don't bother with putting parentheses. But that is really what it is referring to.
No, I got it.
You
I
got it.
didn't realize
It's
that.
just notation. They just don't bother to put the parentheses. It's too much writing, I guess. I don't know.
I like that.
Wait, can you like scroll down to where you did the plot?
Oh, yeah, this was with just the power rule, chain rule.
Yeah. So how come we don't do the derivative of the inside of like?
We did.
Oh, because
Right here. I just use y prime just to save time from.
Oh, okay, yeah.
Power rule, chain rule. That's just a different way to write it. But you still get the same answer. I probably would have picked that method over the other one, but it's fine. It worked. Okay, this next page is not implicit differentiation. This is just practicing for rational powers. We've actually done some of this already. In fact, in the first set of rules I gave you, I said it's true for integers and also rational powers. So what would be the derivative of 4x to the -1/2?
Negative 2x to the negative 3/2.
If you can rewrite something in with a positive power, then that would be considered simplified form.
Can you write it on steps? Like, why didn't we multiply it by by another x?
This is not, okay, this is not chain rule at all. This is straight, this is -1/2 for, whoops, I don't want to put it all. -1/2 times 4x to the -3/2, because I take one away. This is just, it's basically, yeah, this has chain rule in it, the next one. They just, in this particular section, they give you a lot more with rational powers. I know I kind of exposed you to it earlier, but they give you a lot more problems here. This is not implicit differentiation. This is just the product rule, but chain rule with the second part. So it's x times 1/2, keep the inside the same, to the -1/2, times derivative of the inside, 3x squared. That was just the first part. Plus,
Why is it x
Wait,
times?
why is
Shouldn't it
it
be 1? Because the derivative of x is 1.
No, but-
And begin 1.
no, oh, I kept the first part the same times the derivative of the second. If you did it the other way around, that's fine.
Wait, but it.
Next time I'm gonna make that a 1 and keep the second part
Oh, product rule.
product rule, exactly.
Oh.
So So this one was product rule, but I had to do the chain rule here. I didn't have to do it here because it was just an X. Sorry, is that, we're okay now? Okay. Let me, yes, Natalie.
This is not a change, one question that I came across a couple times. With the 3x squared, so multiplying that as the inside, how come we don't do the derivative of that again? Like, does that
Well,
just make sense? Like the inside,
What's the
the inside,
it's just the derivative of this. There's nothing else to do the derivative of.
so like you wouldn't then do like,
There's only,
Six
okay,
X.
if you just look at this, how many compositions do you have? You have an outside 1/2 and an inside x to the third plus 1.
so we wouldn't keep doing.
If this was a 1/2 here and maybe sine of 3x, like if you had another
Okay, I see
function
what you're saying.
within that, then you would do it again. But you don't need to. Okay, we can simplify this. This is not simplified. We'll stop after this one and we'll leave the other two for tomorrow. It's a lot of information today. Okay, well, here, before we do that, let me just combine these. What do we have? 3/2 x to the third. Now, remember when I talked about factoring out the smaller, the one with the smaller exponent? See, I have an x plus 3, or sorry, x cubed plus 1 and an x cubed plus 1. This is to the negative 1/2, this is to the 1/2. So I want to take out the smallest one. That's going to be the negative 1/2.
For what reason?
Because this is not considered simplified. If you left your answer that way, I would not give you full credit because it's not, I know. I'd give you half.
95%.
Maybe half.
Only half? We did all the hard work
But
though.
the hardest part is simplifying. And on the AP, they will always put it in simplified form.
You mean
Like,
the
they'll
AP
give like
doesn't
multiple
provide
choice. This would be like a multiple choice type question.
Yeah.
And your only choice, they would never give you a choice that looks like this. It would be in simplified form, so you have to be able to choose. Okay.
How many questions are there?
There are 35, there's, no.
Are we supposed to show work or just kind of
45,
figure it out?
sorry, 45. There's 28 no calculator and 17 calculator. And that's like half your, and then you have 2 calculator free response
How
and
long does-
4 no calculator free response.
How long do those free response take?
They give you basically they give you 15 minutes for each free response question.
Is it an ABC?
It is an ABC, usually 3 or 4 parts.
Is there, our final isn't a practice test because we can't, we won't know all the material yet.
Whole first semester? No.
Second semester.
First semester, your first semester final is like a handwritten test, like
Yeah.
how I normally. Second semester is like a mini AP.
And do we take it during finals week or before the AP exam?
It's complicated this year with the seniors, so we'll see. I'm still trying to figure it out.
Yeah, why don't we do it?
Because the seniors have a senior capstone project and they might,
I don't think
it's.
it doesn't affect the AP class.
It doesn't.
It doesn't, but it does affect the way,
Cause we're supposed to be taking finals.
because you guys are going to be gone after AP, you'll still be part of the internship.
Yeah.
Finals, because they're talking about doing finals,
Oh,
right after the
AP.
Shabbaton.
That was like March 17th or something.
Yeah.
Finals after the Shabbat.
Not for us, for them.
No, but
For
still
them.
that makes no sense.
So I'm not
Makes
sure
perfect
if I want to do, it's complicated. We'll
We'll
figure it
discuss
out.
it. It's
Okay,
October.
you're, let's get,
I'm getting
let's
it.
finish this so you guys have a
You
little
don't
bit more.
procrastinate.
What?
You don't procrastinate.
What, you don't?
You don't.
Oh, I don't procrastinate. But they don't have the whole they don't have everything finalized with the seniors, so it's hard for me to figure out what. Trust me, I've given it thought. I've already thought, I think, way in advance. More so than I probably need to. What do I get when I factor that out?
I don't remember.
I don't remember.
Do you remember? Okay. I'm gonna squeeze something in here and let me just explain. When I remember when I factor something out, it says if I'm dividing the terms by that. So if you want to imagine like a little x plus 3 or x cubed plus 1 to the negative 1/2. What do you notice?
You add.
These are identical, so what do you do with the exponents? You
One.
subtract them.
So it's just
What's
one
1/2
cubed
minus
plus
a-
one minus 1/2
one.
plus.
So 1. So you end up with an x cubed plus 1.
Wait, so why are you subtracting them if, oh.
I think we might need to practice a little bit more of
Yeah.
this factoring
Yes.
stuff,
Yeah.
okay? Because this is important. And then when you combine these,
5 over 2.
Oh, you want 6 minus.
yeah, 5 over 2. Is that right? Yeah.
Yeah, 5 halves.
So
Well,
5
can you put
halves,
the proportion
x
at
to the
bottom
third
anyway?
plus 1 over x cubed plus 1 to the 1/2.
At the bottom.
5.
Yeah, this still is not simplified all the way. No, it's not. But I'll stop there. I'll stop there for practical purposes. No, because this is a complex fraction still because you have a fraction within a
Just put
fraction.
the 2 under
So
me.
you could, yeah, then you would have to make that a 2.
Why?
So it would be 5x to the, what do you mean why? You have
I don't
to,
know
you
why.
just put the 2 here.
Why not?
If it was all over 2, then you could, but it's just this part's over 2. Okay, good news is, tomorrow's class, is all review of what we did today. So you have the homework
What about
assignment.
review of change?
Yeah, I have a practice. So what we'll do tomorrow is we'll go over the homework. We have these 2 examples. C, I'm not, C, I was gonna say C and C. C, I'm not so worried about, but C I am worried about.
This case, if you're
Because
killing us.
this has something similar to this one.
This case, if we're dying.
Thank you.
No, you're not. You're
So
not.
that-
You're living life and enjoying calculus. So, all right, today was kind of rough, but
Can anyone
Are you
enjoy
going now?
calculus?
I am. I just want to run because I've been teaching and then I teach straight through till lunch and then I have a meeting. So let me have like a 5-minute break and then I'll be back. I just need to go grab something to eat. And
That sounds like my day. I have class then club meeting.